Welcome back to Kamal Kunj Home Academy. Encounter with the art and science of ceramics. In this session, we will discuss about the manufacturing process of magnesia-carbon refractory bricks. Now, magnesia-carbon and alumina magnesia-carbon are two carbon-containing refractories used in steel making vessels. Magnesia-carbon refractories having different amounts of graphite are used in different zones of basic oxygen furnace and slag zone of steel ladles. Alumina magnesia-carbon bricks are used generally in metal zone of steel ladles and in the bottom of steel ladles. Now, the steps for various steps for the manufacture of magnesia-carbon bricks are: number one, first step is the selection of raw materials. Number one step is selection of raw materials. Now, the various raw materials for the manufacture of magnesia-carbon bricks are: number one, seawater magnesia. Seawater magnesia. It is also called premium periclase magnesia. Premium periclase magnesia. And second is fused magnesia. Now, the properties of seawater magnesia and fused magnesia are shown here in the tables. Now, the impurities present are lime, silica, alumina, and iron oxide, Fe2O3. Now, these impurities should be as minimum as possible. Total impurities should not be more than 2.5%. Besides these impurities, seawater magnesia also contains B2O3, boron trioxide. This is very harmful impurity. It should not be more than 0.01%. It should be as minimum as possible. Now, the next is flake graphite. Flake graphite. Fixed carbons should be 95 to 98%. As content would be 2 to 5%. And volatile matter should be less than or equal to 1.2%. Moisture, if any, moisture content should be less than 0.5%, and particle size should be minus 80 plus 200 mesh. Now these are the specification of flake graphite needed for making magnesia-carbon bricks. Next raw material is aluminum metal powder. Purity should be purity of aluminum metal powder. Aluminum content should be minimum 99.5%. And in this aluminum powder, silicon should be 0.15%, and Fe content should be 0.4%. And particle size be minus 325 mesh. Aluminum metal powder acts as an antioxidant. It prevents the oxidation of graphite. Graphite is non-wetting in character, so it improves slag resistance, spalling resistance, and improves the high temperature load bearing capacity. Now the next raw material is peach powder. Peach powder also acts as binder, and it also improves the hot load bearing capacity, strength at high temperature. Peach powder size should be particle size be minus 0.3 mm. It acts as a binder binder and helps in improving the high temperature strength. Now these are the raw materials required for manufacture of magnesia-carbon refractory bricks. Now the next step is processing of raw materials. Next step is processing of raw materials. Now the lumps of seawater magnesia and fused magnesia are processed through seawater magnesia and fused magnesia lumps are processed through jaw crusher, roll crusher and hammer mills. This is called crushing, grinding and screening. Crushing, grinding and screening is done is carried out into different size fractions. Such as 3 to 5 mm size, 3 to 5 millimeter, 1.6 to 3 millimeter, and 0.5 to 1.6 millimeter, and 0 to 0.5 millimeter size. In this size, after crushing, grinding, screened through, these size fractions are stored in overhead silos, from where these are taken for making the batch. Now, the figure shows the process flow diagram for manufacture of magnesia-carbon bricks. So the next step is grading and batch preparation. Grading and batch preparation. Now the proportion of these fractions of magnesia is called grading. Now grading of magnesia-carbon bricks is different from grading of normal magnesite bricks due to presence of graphite. The reason is morphology of magnesia grains and graphite are quite different. Magnesia grains are isometric in nature. So, third step is grading and batch preparation. Now, grading of magnesia-carbon bricks is different from that of normal magnesite bricks due to graphite content, because morphology of magnesia grains is isometric in nature, while graphite morphology of magnesia grains is different from that of graphite. Magnesia grains are isometric in nature, while aspect ratio of flake graphite is around 60. So grading of magnesia-carbon bricks is different from that of normal magnesia bricks. Now grading can be calculated using Anderson's equation. Anderson's equation, according to which y is equal to 100 d by d n, where y is weight% of material less than D, and capital D is maximum size of material. and small n is an empirical parameter. Now this empirical parameter depends on the graphite content. This empirical parameter value of n depends on the graphite content. This is the graphite percentage. And value of n. If graphite is nil, value of n is 0.4. 53%, then also value of n is 0.4. If graphite content is 5%, value of n is 0.5. If graphite is 10%, value of n should be 0.7. If it is 15%, value of n varies between 0.7 and 0.8. If graphite content is 20%, then value of n varies between 0.8 to 1.0. So using Anderson's equation, you can calculate the grading of batch composition. Now we will discuss in a different session about Anderson's equation, how to calculate the grading. Here we will take a typical grading for magnesia-carbon bricks. Let us take a typical grading . Typical composition for typical composition for magnesia-carbon bricks. A typical batch composition. Here, sea-water magnesia 3 to 5 mm, sea-water magnesia 1.6 to 3 mm, sea-water magnesia 0.5 to 1.6 mm, and seawater magnesia 0 to 0.5 mm, and then ball mill fines. This is ball mill fines. Minus 0.5 mm. So this should be around 20%. This fraction should be 23%. 0.5 to 1.6 should be 10%. This also 10%, and ball mill fines 25%. and graphite. Let us make a magnesia-carbon bricks containing graphite content 10% and aluminum metal powder 2%. And then it will be pitch powder 2% and resin 3.4%. Now these two are added, pitch powder and resin are added as supernumerary. As supernumerary. On the raw material, different resins are available in market for making magnesia-carbon bricks. We will discuss a brief here. We will discuss in detail in a separate session, but here we will discuss very brief about resin. There are three types of resins used in magnesia-carbon bricks for making magnesia-carbon bricks. Resins. Dissolved type, phenol formaldehyde, resin, phenol dissolved type, liquid phenol formaldehyde resin. Number 2 is novolite type, liquid phenol formaldehyde resin. And third one is novolite type powder phenol formaldehyde resin, PF resin. Now we will discuss separately in different sessions about the resins, its effect on the property of magnesia-carbon bricks. Here we will be using dissolved type resin. The shelf life for dissolved type resin is, liquid resin is only 2 months. So it should be used before 2 months, in 2 months time from the date of manufacture. So next step is mixing. Batch is prepared taking these size fractions of seawater magnesia from the overhead silos in batch making car, and then charge into the mixer. Then we will discuss mixing. how mixing is done, mixing sequence. Next step is mixing. Mixing sequence. How batch mixing should be carried out for making magnesia-carbon bricks. Next is mixing. And aging. Now mixing is carried out in counter-current planetary mixer, counter-current mixer. Order mixing sequence. Step 1. In step 1, pre-mixing of ball mill fines. Of ball mill fines plus aluminum metal powder plus pitch powder. Aluminum metal powder and pitch powder are pre-mixed into ball mill fines. Mixing is done for about 10 minutes. Then step 2. In step 2, coarse fractions are charged into the mixer. See water magnesia, coarse fractions, that is 3 to 5 mm plus 1.6 to 3 mm plus 0.5 to 1.6 mm are charged into the mixer plus binder, that is resin. About 70% of total quantity required of resins, of total amount of resin required is charged into the mixer containing coarse fractions and is mixed for 10 minutes. Now step 3. After mixing for about 10 minutes, this is a step 2 plus graphite. The required amount of, that is 10% graphite, is added to the mixer after mixing for 10 minutes, and it is further mixed for 10 minutes. And step 4, this is a step 3. After mixing for 10 minutes, the fraction seawater magnesia fraction 0 to 0.5 plus premix ball mill fines containing aluminum and pitch powder. Already pre-mixed material is added and further mixed for and plus rest of the resin, that is 30%. Balance resin that is remaining 30% of the total quantity required is added and mixed for 15 minutes. Now, after mixing, next step is aging. Next step is, after proper mixing, aging is done for 20 to 30 hours depending on the type of resin used and climate conditions. Aging is required. After aging, it is pressing is done. Next step is pressing. Pressing is done at a specific pressure of some 2 ton per centimeter square. Pressing is done at a specific pressure of 2 ton per centimeter square. Pressing is done either in friction screw press or hydraulic press. After pressing, curing or tempering of the bricks is carried out. So next step is tempering. Tempering is carried out at temperatures 110 degrees Celsius to 300 degrees Celsius. Tempering schedule is shown here in the photograph. Initial heating rate should be slow so that surface do not get hardened. Otherwise it will create problem for removal of volatile metals and moisture. So initial heating should be slow as shown in the heating schedule diagram. And after tempering, it is inspection and testing is done. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.